Space, the last great frontier, both breathtaking and deeply unsettling. It stretches endlessly in every direction, filled with infinite mysteries, unexplainable phenomena, and unimaginable beauty. The eerie silence of the cosmos has always fascinated me, so I decided to dive headfirst into it, to explore the space iceberg and uncover every strange fact, wild theory, and bizarre mystery hidden within. So, without wasting any more time, let's start exploring the unknown. We'll begin with something everyone knows: the 8 planets of our solar system. Closest to the Sun is Mercury, the smallest and fastest planet, baking under intense heat. Next is Venus, often called Earth's sister planet because of its similar size and composition, though its surface is anything but friendly. Then, of course, we have Earth, our home, the only known world to host life. After that comes Mars, the famous red planet, covered in rust-colored dust and mountains that dwarf anything on Earth. Beyond Mars, we reach the gas giants, massive planets made mostly of hydrogen and helium. Jupiter reigns as the largest planet, with its swirling storms and faint rings, while Saturn is known for its stunning, wide ring system made of ice and rock. Further still are the ice giants: Uranus, the sideways planet with its strange tilt, and Neptune, the distant blue world whipped by supersonic winds. According to the International Astronomical Union, these are the 8 official planets, excluding Pluto, which was reclassified as a dwarf planet in 2006. Don't worry though, we'll come back to Pluto and that whole controversy later in the iceberg. At the heart of it all sits the Sun, the blazing center of our solar system, the giant nuclear furnace that keeps everything alive. This enormous sphere of plasma, made mostly of hydrogen and helium, provides nearly all the energy that sustains life on Earth. The Sun's gravity keeps every planet, moon, asteroid, and comet locked in orbit. It's around 4.6 billion years old, currently in the stable phase of its life, where hydrogen atoms fuse into helium deep within its core, releasing staggering amounts of light and heat. The surface of the Sun burns at roughly 5,500 degrees Celsius, or about 9,932 degrees Fahrenheit for those in the US. But the core? That's millions of degrees hotter, a realm of pure nuclear chaos. Every flicker of sunlight we see is a product of those reactions, and that same energy drives Earth's weather, ocean currents, and climate. Quite literally, without the Sun, nothing would exist. In the vast vacuum of space, there's almost nothing. No air, no wind, no pressure. Between planets and moons lies an emptiness that stretches for light years, completely void of breathable atmosphere. Earth's atmosphere fades thinner and thinner until it finally disappears into this vacuum. Because there's no air, space can't support life as we know it. There's also no air pressure, something we take for granted here on Earth. In space, that lack of pressure can cause fluids in the human body to boil away, which is why astronauts rely on heavily pressurized suits just to survive. Another strange result of the vacuum: silence. Sound waves need a medium, air, water, or solid matter, to travel through. Since there's none of that in space, sound simply can't move. So, those silent space scenes in sci-fi movies, they're actually accurate. Inside a spacecraft, though, there's air, so astronauts can hear each other just fine. Every astronaut depends on life support systems not only for oxygen, but also for temperature regulation and radiation protection. While planets and moons might have their own thin atmospheres, the vast distances between them remain utterly empty, an endless void of nothingness. Now, let's talk about the Moon, the other big object lighting up our night sky. Earth's natural satellite orbits us at an average distance of about 238,855 miles away. It's the fifth largest moon in the solar system and plays a crucial role in many of Earth's natural systems. As it circles our planet, sunlight hits it from different angles, creating the familiar cycle of phases, from new moon to full moon and back again. The lunar surface is a landscape frozen in time, filled with craters from ancient impacts, dark plains called maria, formed by old volcanic eruptions, and rugged highlands. Because it lacks a true atmosphere, the moon experiences wild temperature extremes, boiling hot in sunlight and freezing in darkness. Gravity there is about 1/6 of Earth's, meaning astronauts can leap higher and move more easily. The moon's gravitational pull also controls Earth's tides and stabilizes the planet's tilt, which keeps our climate relatively steady. Human exploration of the moon began with Apollo 11 in 1969, but we'll get to that iconic moment later. The moon continues to be a source of fascination and study, offering insight into the history of our solar system.
Humanity's greatest question. Are we alone? Scientists are constantly searching for life beyond our planet, whether that's microbial life on Mars or signs of oceans beneath the icy crust of Europa. Space missions and telescopes study these worlds for clues of habitability. At the same time, the SETI program scans the cosmos for radio signals that could indicate intelligent life. We haven't found proof yet, but each discovery, from organic molecules on Mars to exoplanets in distant solar systems, brings us a step closer to the answer. And don't worry, we'll go much deeper into alien theories later in the Iceberg. It might sound mundane compared to galaxies and black holes, but satellite TV is actually a fascinating product of space technology. Satellite television works by sending broadcast signals from ground stations up to communication satellites orbiting Earth. Those satellites then beam the signal back down, allowing homes with satellite dishes to receive hundreds of channels, from sports to news to international programming. This system revolutionized global communication and entertainment, and it all happens thanks to satellites orbiting high above our planet. Now, let's talk about one of humanity's most iconic figures, Neil Armstrong, the first person to set foot on the moon. On July 20th, 1969, during the Apollo 11 mission, Armstrong stepped onto the lunar surface and delivered the immortal line, "That's one small step for man, one giant leap for mankind." Born in Wapakoneta, Ohio in 1930, Armstrong's fascination with flight began early. He became a Navy pilot, then joined NASA in 1962, combining incredible technical skill with calm precision under pressure. The moon landing was the result of years of teamwork, engineering breakthroughs, and human courage, fulfilling President Kennedy's promise to reach the moon before the end of the decade. After his historic mission, Armstrong went on to teach aerospace engineering and serve in various scientific organizations. He passed away in 2012, leaving behind one of the most inspiring legacies in human history. Still, the question remains, did we really go to the moon? Some conspiracy theorists think it was all staged. Personally, I think that's a topic for another video. But let me know what you believe down in the comments. Next up, the cosmic doomsday scenario, killer asteroids. Also known as potentially hazardous objects, PHOs, these are large asteroids or comets whose orbits bring them close to Earth, close enough to pose a serious threat.
A large impact could unleash energy greater than any bomb on Earth, causing global destruction and mass extinction. That's why scientists constantly track thousands of near-Earth objects. Agencies like NASA and ESA monitor their trajectories, predict potential collisions, and work on strategies to deflect or destroy any asteroid that might come too close. Some proposed methods include using gravity tractors, kinetic impactors, or even nuclear devices to alter an asteroid's path. Humanity might not be able to control the universe, but we're doing our best to make sure it doesn't destroy us overnight. Now we move deeper into the iceberg. The Space Shuttle was one of NASA's most iconic creations, a reusable spacecraft that changed how humans reached orbit. It consisted of an orbiter, where the crew stayed, 2 solid rocket boosters, and a massive external fuel tank. From 1981 to 2011, the shuttle carried astronauts, satellites, and cargo into space. It helped build the International Space Station, launched the Hubble Space Telescope, and conducted hundreds of missions. But due to aging hardware, high costs, and 2 tragic disasters, the program was eventually retired. Still, it remains one of the most recognizable symbols of human exploration. Before the Americans made it to the moon, the Soviets made history in orbit. Yuri Gagarin, a Soviet cosmonaut, became the first human to journey into outer space on April 12, 1961, aboard Vostok 1. His flight lasted just 108 minutes, orbiting Earth once at an altitude of about 200 miles. As he took off, he radioed the now famous words, "Поехали," let's go. Gagarin's mission made him an instant hero and a global icon, marking the start of the human space age. Sadly, he died in a training accident in 1968, but his achievement remains one of the most important milestones in human history. Now, let's talk about where it all began. The Big Bang. Around 13.8 billion years ago, the universe began as an unimaginably hot, dense point, and then expanded rapidly. This event created all matter, energy, and space itself. Over time, the universe cooled, forming atoms, stars, galaxies, and eventually, us.
Evidence of this event still exists as cosmic microwave background radiation, a faint glow left over from the universe's birth. The Big Bang remains the most widely accepted explanation for how everything began, though what caused it, or what existed before it, remains one of science's greatest mysteries. We touched on this earlier, but let's dig deeper. Sound can't travel through a vacuum. It needs a medium, air, water, or solid matter, to move as vibrations. In the emptiness of space, there's nothing for those vibrations to pass through, which is why space is completely silent. Inside spacecraft, however, sound exists because there's air inside. That's why astronauts can talk and hear equipment operating. Movies often add dramatic sound effects for storytelling, but in reality, the universe is eerily quiet. Let's circle back to Pluto, because its planetary status caused one of the biggest debates in astronomy. Discovered in 1930, Pluto was long considered the 9th planet, but in 2006, the International Astronomical Union introduced new criteria. It must orbit the Sun, it must be spherical, it must have cleared its orbit of other debris. Pluto checks the first 2 boxes, but not the third, since it shares its orbit with many icy bodies in the Kuiper Belt. Because of that, Pluto was downgraded to a dwarf planet. Many people still feel emotionally attached to Pluto's old title, and the debate continues even today.
Some scientists believe the definition of planet should be updated again, so the story isn't over yet. Orbiting about 250 miles above Earth, the ISS is humanity's home in space, a joint project between NASA, Roscosmos, ESA, JAXA, and CISA. Traveling at 17,500 miles per hour, it circles Earth every 90 minutes, meaning astronauts see 16 sunrises and 16 sunsets each day. The ISS functions as a massive science lab, conducting research in biology, physics, astronomy, and more. Experiments there help us understand how humans adapt to long-term space living and guide the future of deep space exploration. It's also a symbol of what humans can accomplish through international cooperation. For thousands of years, people have looked up at the stars and drawn shapes among them. Constellations. These star patterns, like Orion, Ursa Major, or Leo, helped ancient travelers navigate and inspired countless myths. The International Astronomical Union officially recognizes 88 constellations, dividing the entire night sky into mapped regions. Even though the stars in a constellation might be light years apart, from our viewpoint on Earth, they appear grouped together. They remain a bridge between science and storytelling, a reminder of how humans have always searched for meaning in the stars. You can't talk about modern space exploration without mentioning Elon Musk. Born in 1971 in South Africa, Musk became one of the most influential innovators of our time. Through Tesla, he helped push the world toward electric vehicles and sustainable energy. But his biggest impact on space came through SpaceX, the private company aiming to make space travel cheaper and, eventually, colonize Mars. SpaceX achieved milestones like landing reusable rockets, sending cargo and astronauts to the ISS, and developing the powerful Starship spacecraft. Musk also leads projects like Neuralink and The Boring Company, blending technology, science, and vision in ways that have reshaped multiple industries. Now for an existential reminder. Yes, the sun will eventually die. Like all stars, it has a life cycle. Right now, it's in its main sequence phase, fusing hydrogen into helium. But in about 5 billion years, it'll run out of fuel, expand into a red giant, and grow so large it might engulf Mercury, Venus, and even Earth. Eventually, it'll shed its outer layers and shrink into a white dwarf, slowly cooling over billions of years. That's the fate of most stars. And someday, our sun will just be a dim ember in space. The Curiosity rover, part of NASA's Mars Science Laboratory mission, launched in 2011 and landed in Gale Crater on August 6, 2012. Weighing nearly a ton, Curiosity was built to explore Mars's surface, study its geology, and search for signs that life might have once existed there. It's discovered dried-up riverbeds, traces of organic molecules, and evidence that Mars once had the right conditions for life. Originally meant to operate for just 2 years, Curiosity has far outlived its mission, continuing to send back incredible data more than a decade later. It's one of the most successful robotic explorers in history. The phrase, "We choose to go to the moon," comes from President John F. Kennedy's legendary 1962 speech at Rice University. In it, Kennedy challenged America to achieve something monumental, to land a man on the moon and return him safely to Earth before the decade ended. His vision inspired the Apollo program, culminating in the success of Apollo 11 in 1969. That single line,
became a defining symbol of human ambition, innovation, and the belief that no goal is too great when humanity works together. Sputnik, the word means satellite in Russian, was the first man-made object to orbit Earth. Launched on October 4, 1957, it was a polished metal sphere that transmitted a simple beeping signal heard around the world. Sputnik's launch shocked the globe, marking the start of the space race, and proving that the Soviet Union had advanced technology capable of reaching space. Now for one of the most mind-bending theories, the simulation hypothesis. It suggests that reality itself might not be real, that everything we see and experience could be part of a hyper-advanced computer simulation. Think The Matrix, but on a cosmic scale. Proponents argue that as technology advances, creating entire simulated universes will become possible. And if that's the case, how would we ever know we're not already in one? Some even point to strange quantum behaviors or glitches in physics as possible clues. Exoplanets, or planets beyond our solar system, are one of the most exciting fields in modern astronomy. These worlds orbit distant stars, and scientists discover them using methods like light dimming, transits, star wobbling, radial velocity, direct imaging, and gravitational lensing. Some exoplanets are massive gas giants, while others are rocky and Earth-sized. The most intriguing ones lie in the habitable zone, the sweet spot around a star where liquid water could exist. Thousands of exoplanets have already been discovered, each revealing how diverse and strange planetary systems can be, and how possible it might be that life exists elsewhere. One of the weirdest planets in the solar system is Uranus, the sideways planet. Unlike the others, Uranus rotates almost completely on its side, with an axial tilt of about 98 degrees. This means it basically rolls around the Sun instead of spinning upright. Because of that, each pole experiences about 42 years of constant daylight, followed by 42 years of darkness. Scientists believe this tilt may have been caused by a massive collision long ago. Whatever the case, Uranus remains one of the strangest worlds in our cosmic neighborhood. And finally, we end with the speed of light, the universal speed limit. In a vacuum, light travels at about 299,792 kilometers per second, or roughly 186,282 miles per second. That's fast enough to circle Earth more than 7 times in a single second. According to Einstein's theory of relativity, nothing with mass can move faster than light. This limit defines how we measure distance in space, light years, and shapes our understanding of time, gravity, and the structure of the universe itself. When you look at stars, you're actually looking back in time, seeing light that left those stars years, centuries, or even millennia ago. This speed, the speed of light, stands as one of the universe's unbreakable limits. Nothing with mass can ever surpass it, no matter how much energy is used. That's why it serves as a cosmic yardstick, defining both distance and time across the cosmos. When we look up and see the stars twinkling, we're actually staring into the past. The light that reaches our eyes has traveled for years, sometimes thousands, even millions of years, just to get here. The night sky isn't a snapshot of the present. It's a vast time machine showing us how things used to be. And that brings us to the next level of the iceberg. Now we're diving beneath the surface, into the stranger, more mysterious, and sometimes eerie side of space. Let's begin with dark matter. Scientists estimate that everything we can see, stars, planets, gas, galaxies, makes up less than 5% of the total universe. The rest? It's invisible. About 27% is dark matter, a form of matter we can't see, touch, or detect directly,
Yet its gravitational pull is strong enough to hold galaxies together. Without it, the Milky Way would fly apart. Even stranger is dark energy, which makes up roughly 68% of the universe and is responsible for its accelerated expansion. That means most of existence is something we can't see and don't understand. We only know it's there because of how it affects everything else. Next, let's talk about black holes, the most extreme objects in existence. They're formed when massive stars collapse under their own gravity, compressing all their mass into a point so dense that not even light can escape. The boundary around this point is called the event horizon. Cross it, and there's no way out. At the center lies what physicists call a singularity, a place where the laws of physics as we know them simply break down. Space and time lose their meaning there.
Despite their terrifying reputation, black holes aren't just cosmic monsters. They also play a crucial role in shaping galaxies and regulating star formation. In fact, at the center of nearly every galaxy, including our own, there's a supermassive black hole, millions or even billions of times heavier than our Sun. The one in the middle of the Milky Way is called Sagittarius A star. If it were visible, it would appear about the same size in the sky as a donut sitting on the moon. But let's go even darker, to the concept of white holes. A white hole is essentially the opposite of a black hole. Instead of swallowing everything, it would eject matter and light. Theoretically, nothing could enter it. Some scientists think white holes could be connected to black holes. Whatever falls into one might emerge from the other somewhere else in space, or even in another universe. It's purely theoretical for now, but it raises fascinating possibilities about wormholes, time travel, and the fabric of reality itself. Speaking of strange celestial bodies, let's talk about neutron stars. When a massive star explodes in a supernova, its core collapses under gravity until the atoms are crushed so tightly that protons and electrons merge into neutrons. What's left behind is a sphere only about 20 kilometers wide, yet heavier than the Sun. A single teaspoon of neutron star material would weigh around 1 billion tons. And some of them rotate incredibly fast, hundreds of times per second, emitting beams of radiation that sweep across space like cosmic lighthouses. These are called pulsars. Now let's shift to something closer to home, but just as mysterious: the Oort cloud. It's a vast, distant region surrounding our solar system, stretching almost halfway to the nearest star. This cloud is thought to be a reservoir of icy comets, remnants from the formation of the solar system. Whenever a comet suddenly appears in our sky, it might have traveled for millions of years from the Oort cloud before finally making its fiery approach toward the Sun. Next up, rogue planets. Not all planets belong to solar systems. Some wander alone through the galaxy, drifting in total darkness without a star to orbit. Scientists believe there could be billions of these rogue planets, worlds that were either ejected from their home systems or formed on their own. Imagine a planet floating in endless night, its only light coming from distant stars millions of miles away. It's haunting, but it's real. Now let's move to one of the most spectacular phenomena in the universe: supernovae. When a massive star reaches the end of its life, it can explode with such incredible force that for a brief time, it outshines entire galaxies. These explosions forge the heavy elements, like iron, gold, and silver, that make up our world and our bodies. Every atom of gold you've ever seen was created in a star's death. Supernovae are not just cosmic destruction, they're also creation itself. But not every star dies in an explosion. Some end their lives quietly,
turning into white dwarfs, the cooling remnants of smaller stars like our Sun. Over billions of years, these remnants fade into theoretical black dwarfs, cold, dark objects that no longer emit light. The universe isn't old enough for any black dwarfs to exist yet, but someday they'll be all that's left. Now let's talk about something that captures everyone's imagination: extraterrestrial life. With billions of galaxies, each containing billions of stars and countless planets, the odds suggest that life must exist elsewhere. Scientists have already discovered thousands of exoplanets, worlds orbiting other stars, and some of them lie in what's called the habitable zone, where conditions might allow liquid water to exist. Still, we've found no definitive proof of life beyond Earth. The Fermi paradox asks, if intelligent life is so likely, why haven't we seen it yet? Are we alone? Or is everyone else just too far away to reach us? And finally, let's look at one of humanity's biggest engineering failures: the N-1 moon rocket. During the 1960s space race, the Soviet Union designed the N-1 to compete with NASA's Saturn V rocket and send cosmonauts to the moon. On paper, it was incredibly powerful, the largest rocket ever built by the USSR. But in reality, it was a disaster. Every one of its 4 test launches ended in failure. The first exploded seconds after liftoff. The second crashed back to Earth in a fireball so massive it destroyed the launch pad. The Soviets covered up these failures for years, and by the time they perfected the design, the US had already landed on the moon. The N-1 remains one of the most ambitious and catastrophic rocket projects in history.
Long before humanity first gazed down from space, some have speculated that others may have ventured there in secrecy. The notion lingers that the Soviet Union could have launched cosmonauts before Yuri Gagarin's historic flight in 1961, missions that perhaps ended in tragedy and were carefully concealed. Stories emerged, particularly after the fall of the Soviet Union, of intercepted radio transmissions hinting at astronauts who never returned, their fates lost to the cold void. While historians and space experts remain skeptical, dismissing these claims as lacking verifiable evidence, the idea of lost pioneers drifting silently among the stars continues to capture the imagination. The universe itself, vast and enigmatic, holds mysteries that challenge our understanding. One of the most profound is the invisible mass that binds galaxies together, dark matter. Though it neither emits nor absorbs light, its presence is revealed in the gravitational dance of stars and galaxies, shaping the cosmos in subtle yet monumental ways. Scientists continue to probe its nature, using intricate experiments, observations, and simulations, striving to uncover the identity of this unseen architect of cosmic structure. Closer to home, the Moon presents a very tangible challenge to explorers. Its surface, blanketed in fine, abrasive dust, poses a threat to both machinery and human health. Lunar regolith clings stubbornly to spacesuits, scratches delicate instruments, and, if inhaled, could irritate or harm those who tread upon it. Engineers work tirelessly to develop ways to manage this stubborn dust, knowing that mastering it is essential for the next era of lunar exploration. Far beyond our solar system, the imagination stretches to worlds that might exist only in theory. Some exoplanets, born in carbon-rich environments, could be composed largely of diamond, forged under immense pressures and temperatures. These hypothetical planets spark visions of alien landscapes glittering with crystalline formations, yet none have been observed directly. The pursuit of knowledge about such exotic worlds continues, pushing the boundaries of what we consider possible. Meanwhile, human ingenuity seeks propulsion beyond conventional fuel. Solar sails, vast reflective membranes,
harness the momentum of sunlight itself. Though the force is faint, it is continuous, nudging spacecraft forward across the silent emptiness, offering a path to journeys unbounded by traditional energy constraints. Over time, these sails could carry explorers to distant realms, propelled only by the gentle pressure of light. Even the artifacts humans leave behind in space are subject to the unyielding forces of the cosmos. The flags planted on the lunar surface during the Apollo missions, once vivid and proud, have likely faded to pale shadows of their former colors. Bombarded by ultraviolet light, extremes of temperature, and micrometeorite impacts, they now stand as silent witnesses to humanity's first steps beyond Earth. The story of the universe itself is one of extraordinary beginnings. In the earliest moments after the Big Bang, space expanded at unimaginable speeds, smoothing out the cosmos and setting the stage for galaxies to form. This period of cosmic inflation explains the remarkable uniformity we observe today, offering a glimpse into the formative seconds of all that exists. Exploration, however, has always carried risks. The Apollo 1 mission, intended as a simple test of the command module, ended in tragedy when a fire claimed the lives of 3 astronauts, revealing flaws in design and safety that reshaped the Apollo program. Similarly, the Mir space station faced fires, collisions, and equipment malfunctions over its long tenure in orbit, testing the resilience and ingenuity of its crew and mission controllers. Fundamental laws govern our understanding of movement and forces. Einstein's insight revealed the equivalence of acceleration and gravity, showing that what we perceive as a gravitational pull is inseparable from the curvature of space-time itself. This principle reframes gravity, not as a force, but as the very geometry of the universe, guiding the paths of planets, stars, and light. Other celestial bodies continue to astonish. Titan, Saturn's largest moon, hosts seas and lakes of liquid methane and ethane, stretching across vast landscapes and shaped by cycles reminiscent of Earth's water systems. Signals from the cosmos, like the mysterious WOW signal detected in 1977, tantalize scientists with the possibility of other intelligent life, reminding us of how much remains unknown.
Space exploration has claimed its heroes. Vladimir Komarov perished when his spacecraft's parachute failed, sacrificing himself in a mission fraught with peril. The Soyuz 11 crew met a similar fate when an air vent malfunction led to the asphyxiation of the astronauts upon re-entry. Yet courage persists, with LGBTQ+ astronauts like Sally Ride and others leaving their mark on space history, dimmed understanding that diversity and dedication transcend even the most extreme environments. The cosmos itself is alive, with phenomena both destructive and awe-inspiring. Quasars blaze with energy from supermassive black holes, while solar storms like the Carrington event of 1859 remind us of the sun's power to disrupt civilization. Stars like Tabby's star challenge our understanding, dimming mysteriously and fueling speculation from comet swarms to alien megastructures. Saturn's rings, meanwhile, slowly erode, hinting at the transient nature of even the grandest celestial features. Eclipses occur not by chance, but by precise alignments, a cosmic choreography of the Sun, Moon, and Earth. Gravity, as understood through relativity, curves the very fabric of space-time, and once mythical Martian canals are now known to be optical illusions, the mind's tendency to perceive patterns where none exist. Humanity has even sent ashes into the outer solar system, symbolic journeys marking our presence beyond Earth. Our understanding of the universe stretches to dimensions beyond perception. Space and time merge into a four-dimensional continuum, guiding the motion of planets and the flow of light. Human engineering has mirrored these ambitions, with the Soviet Buran shuttle and NASA's space shuttles venturing into orbit, demonstrating both technological prowess and the risks inherent in reaching for the stars. Missions like Soyuz 11, Pioneer 10 and 11, and the exploration of Mars continue to challenge our knowledge. While water flows no longer in visible Martian waterfalls, the planet's valleys and briny seeps hint at ancient activity. Astronauts face conditions like space blindness, altered vision caused by prolonged weightlessness, while the smallest debris, from paint flecks to micrometeorites, tests the resilience of spacecraft windows and materials. In the vast expanse, the story of humanity's exploration unfolds, a tapestry of ambition, risk, curiosity, and wonder. From lost cosmonauts and tragic accidents to the gentle push of solar sails and the mysteries of distant stars, our journey into space is a reflection of our desire to understand the universe. Each orbit, each signal, each observation carries the weight of discovery and the promise of the unknown, reminding us that for all we have learned, the cosmos still holds secrets beyond imagining. In 2017, an interstellar visitor passed silently through our solar system. Known as Oumuamua, its elongated form and unusual trajectory sparked wild speculation. Some whispered it might be an alien spacecraft, a relic of another civilization gliding through the void. Its lack of a cometary tail only deepened the mystery. Yet, despite the intrigue, astronomers lean toward natural explanations. Fragments of a shattered world, peculiar asteroids, or exotic comets. Still, the possibility that it was something extraordinary lingered, teasing the imagination. Beyond our solar neighborhood, the cosmos itself holds secrets that challenge comprehension. A force known as dark energy pervades space, invisible yet powerful, driving the universe's expansion ever faster. Though its origin remains unknown, it is thought to act as a repulsive pressure, shaping the cosmos on unimaginable scales. Albert Einstein once proposed a cosmological constant, and today, scientists continue to seek the true nature of this enigmatic force, knowing it governs the fate of everything we observe. Even the vast structures of the universe can be mysterious and unseen. Hundreds of millions of light-years away lies the Great Attractor, a gravitational anomaly drawing galaxies inexorably toward it. Hidden behind the dense core of our Milky Way, it cannot be observed directly, yet its pull is undeniable, hinting at concentrations of matter far beyond our reach, an invisible hand shaping the motions of countless worlds. At a deeper level, the universe may reveal structures far smaller than we can perceive. String theory proposes that all matter is woven from tiny, vibrating strings, their frequencies dictating the particles we observe. In this view, dimensions beyond the familiar three might curl tightly beyond detection, and the forces of nature, gravity, electromagnetism, and nuclear interactions, could one day be united under a single, elegant framework. Though experimental proof remains elusive, the theory offers a vision of a universe profoundly interconnected at its smallest scales. Closer to home, imagination once ran wild with the mysteries of Venus. Through early telescopes, the planet appeared smooth and clouded, and in the absence of visible features, speculation took flight. Some envisioned swamps and ferns, even dinosaurs roaming beneath its mists. Science fiction writers wove elaborate tales, imagining lush worlds of adventure and peril. But Venus, we now know, is a hellish furnace, its clouds concealing a scorching surface where liquid water cannot survive. The dinosaurs never were, yet the stories endure as a testament to human curiosity. The strange logic of possibility continues to echo in the quantum realm. The many worlds theory suggests every choice, every chance event births parallel universes, each one a branch in an infinite cosmic tree. Quantum immortality proposes that consciousness experiences only the branches in which survival occurs, hinting at a reality where death might never be experienced from a first-person perspective. In this multiverse, infinite worlds exist, where every variation of ourselves plays out endlessly. Mysteries also lurk in our own technologies. The Zuma mission, a classified satellite launched in 2018,
vanished from public knowledge under layers of secrecy, fueling rumors of failure and conspiracy. Even as SpaceX deployed the rocket successfully, the satellite's fate remains unknown, a shadowy reminder of the limits of human observation. Stars, too, have their hidden rhythms. Starquakes ripple through their interiors, seismic echoes of immense magnetic and gravitational stress, while black holes at the centers of galaxies struggle to merge, trapped by gravitational dances that span light years. Across the cosmos, forces interact in ways that are beautiful and terrifying, revealing the complex choreography of the universe. Numbers and superstition intertwine even in human endeavors. Missions like Zoya's TMA-11, carrying astronauts from multiple nations, faced symbolic omens, yet prevailed, reminding us that courage often outpaces fear. Meanwhile, moons like Saturn's Rhea quietly boast rings of their own, subtle structures hinting at wonders beyond the obvious, unseen by all but the most diligent observers. The universe challenges our notions of significance. In a cosmos of infinite galaxies, stars, and worlds, the idea of a single pinnacle of greatness fades. The concept of Boltzmann brains suggests consciousness itself might spontaneously flicker into existence, ephemeral and alone, challenging assumptions about life and reality. Forces that govern the universe might one day merge in a unified theory, revealing hidden symmetries across time and space. From the faint afterglow of the cosmic microwave background, we trace the earliest quantum fluctuations that seeded galaxies, while theories of quantum immortality and the holographic universe hint that reality itself might be information projected from unseen dimensions. Some posit a universe made from a single electron, where mirrored particles trace the same path through time, and astronauts like Edgar Mitchell have suggested that our observations may only scratch the surface of phenomena hidden by secrecy and caution. Even the fabric of reality may not be as solid as it seems. A false vacuum might hide beneath the surface of existence, a delicate balance that could shift with consequences beyond imagination. Concepts like everything is a spine envision a cosmos of interconnected metadata, and perhaps Earth itself is observed within a cosmic zoo by civilizations beyond our understanding. The universe might be a particle, an axis of anomalies, or a projection of pure information. Speculations stretch further still. Stars could be living in ways we only metaphorically understand. Other universes might be encoded in the cosmic microwave background, and the swirling singularities of black holes might allow journeys backward through time. All energy may be waves of a single essence, all events threads in a universal tapestry. In the end, the universe remains vast, enigmatic, and humbling. From interstellar visitors and invisible forces to quantum paradoxes and cosmic coincidences, our journey through space is one of wonder and endless curiosity. We probe, we speculate, we imagine, and in the process, we confront the infinite possibilities of what might be, aware that for every answer we uncover, countless more mysteries await.